All right, proteins. I believe I told you after water, proteins to me, or in my opinion, are the next most important. And of course, if we think skin and muscle and organs and all the filler to go on that skeleton and actually the skin are covered, proteins, guys, are pretty dynamic. I'm asking in there too, hey, give me some specific examples. And don't put maintenance, growth, reproduction, or milk production. I want a little more detail than that, and probably a couple of those slides down. Hey, tissue protein, enzymes and hormones. And this can even go back to our metabolism chart as well. You know, we go back to that metabolism chart of, then guys, this whole deal for every one of these eras involves an enzyme. And if you remember on this area here too, bringing the glucose into the cell, you know, we can actually put insulin in on this. And so insulin is a hormone that forces it. The thing is, when we get so much glucose in the cell, we get all the energy in this deal that we need. Then all of a sudden, what do we have left? I mean, we're going to go to fat and fatty acids. And the body's going to say no more. I don't need any more of those, that glucose in here. And so we got to turn insulin off. And then if we need glucose in the blood, then we're going to actually turn on glucagon, is another protein hormone that facilitates that whole gluconeogenesis and getting glucose back in here into the blood. So these paths in here, these arrows are enzymes. These arrows are getting it up here and changing it, are actually hormones. So when we turn back around and we talk about specifics, there are enzymes for many metabolic pathways that are constantly being produced and then broken down, and those amino acids used for different components. Likewise with protein or with hormones. So really, really dynamic. The other thing is too, when we go back to our metabolism chart that we had, we said that glucose or amino acids, I'll scroll down here. We said these arrows go back and forth. So if this amino acid is needed for energy, then it comes right back over in here or back in the Krebs cycle, and we come right back down to our energy. On the flip side, those same amino acids can go right back up to pyruvate, gluconeogenesis. We scroll right back to the top, boom, right through glucose, and that gives us our glucose that we need to enhance or increase blood glucose levels. So we talked about it from the standpoint of proteins. You know, that same metabolic pathway and chart that you've got to learn at the beginning of this semester. Energy via TCA or Krebs cycle, glucose via gluconeogenesis. The actual eras are the enzymes and the hormones that start all of that. And then tissue protein. And here's just a good image right here of skin. And guys, the dermal layer down here is what has the blood flow, the hair follicles sit in. What you see up top, most of that skin on the outside is dead. So the epidermal layer, we're constantly regenerating from the bottom right up over in here as we come up over time. So that's a total process of constant regeneration, tissue, protein, and repair. We talked about carbohydrates broken up into two different categories, and that's structural, which is the main plant part, and the other is a storage form, which is your seed. And so the structural versus the storage form, proteins, we have amino acids that are two different categories. We have our essential amino acids, which means we can't synthesize them in the diet. And we have our non-essential amino acids that are synthesized in the body. And if I come right back to that same metabolic chart, guys, these amino acids, you probably could just put non-essential here in front of them. And the reason is because we can synthesize them from both intermediates in the citric acid or TCA cycle, as well as pyruvate. We add an amine group and we form the amino acid alanine. And so we can deaminate, we can do whatever. These are your non-essential amino acids because they can be synthesized in the body. The ones that are essential have to be in the diet because we can't make them.